Hey people, so I wanted to make this quick video to go over the answers to the Pear deck that you completed. And so I know this is going to be probably a rather long video, but I think that it's going to be helpful for those of you who want a little bit more detail. We may or may not be able to go over all of the answers when we do our Google Meet on Tuesday. So I just wanted to make this ahead of time, post it for those of you who've already completed it and need immediate feedback and immediate answers. And for those of you who haven't, we'll also go over it in our Google meeting. Okay, so the first question says Grace and Allie are going to meet at the fountain near their house. They both leave their house at the same time. Allie passes Grace's house on the way to the fountain. So important facts in the problem are clearly that Allie's walking at a rate of 2 meters per second. We know that that's an important fact. We also know another important fact is the fact that Grace's distance is or walking rate is 1.5 meters per second. We also show in the picture that Allie's house is 200 meters from the fountain. Grace's house, it doesn't give us the information just yet. So the question asks us, how many seconds will it take Allie to reach the fountain? And so, well, what do you need to do? Well, we know we need to figure out how many seconds, how long it's going to take Allie to get from her house here over to the fountain. So her house is 200 meters from the fountain, and she walks at a walking rate of 2 meters per second. Now, I just want to remind you that when we look at comparing individuals with walking rates, if they have the same time, meaning the same time, we're looking at the unit rate in this case, the person actually who travels further has the greater or faster speed because they're able to get a further distance, but in the same amount of time. So they're walking actually faster. So time is the same, 1 second, but Allie's walking 2 meters per second. Grace is walking 1.5 meters per second. Why is that important in the context of this particular problem? Not necessarily, but if we're asked to compare their walking rates or graph them or something like that, we may need that. So, in any case, what did you have to do? You had to take the distance that Allie's going and divide it by the unit rate, the amount of distance she covers in 1 second to find out how long it's going to take her to go the 200 meters, right? So, this is 200 meters in 2 seconds means or 2 meters per second, rather, it's going to take her 100 seconds or 1 minute and 40 seconds. This is a 1, not a 4, by the way. When I wrote this before, I was kind of being rushed and sloppy. Okay. All right. Next question. Grace and Allie are going to meet near their houses. They both leave their house at the same time. Allie passes Grace's house on the way to the fountain. Okay. We got that information. Suppose Grace's house is 90 meters from the fountain. Who will reach the fountain first? Okay, this is kind of obvi, unfortunately, fortunately, whatever. Grace is going to reach the fountain first. And why do you think? Just take a look at the picture. She's only got 90 meters to reach the fountain. Allie's got 200 meters to reach the fountain. And so, how long is it going to take her to travel those uh, 90 meters? Well, if she's going at 1.5 meters per second, we know that that's Grace's walking rate. It's going to take her 60 seconds. Why? Because we're going to take 90, we're going to divide it by 1.5, because that's the amount of distance she covers in 1 second. That's going to tell us how long it's going to take her to go this 90 meters, right? We could think about setting it up in a proportion if we wanted to. And that proportion, what would it look like exactly? Well, we've got 90 meters we need to cover. And we know she goes 1.5 meters in 1 second. So those are the rates that are equivalent. And so we cross multiply, then divide, or really just divide. Okay. And so Grace is going to hit the fountain first. Okay. All right. Now, next question. Ingrid stops at Tara's house on her way to school. Tara's mother says that she left 5 minutes ago. Okay. All right. Ingrid leaves Tara's house walking quickly to catch up to Tara. The graph below shows the distance each girl is from Tara's house, starting from the time Ingrid leaves Tara's house. So, what do you notice about the graph? Well, you may have noticed something different than I did, but the first thing I noticed was that shows a linear relationship to me. It forms a straight line. It's not doing this, then that. It's not doing this. It forms a straight line. But what I notice immediately is Ingrid starts at 0, 0, and Tara's doesn't. And so I'm wondering, does Tara's graph, is this showing this whole idea of Tara leaving 5 minutes ago? Ingrid, she leaves Tara's house. She's walking really, really, really quickly. But maybe Tara, since she's already 500 meters by the time what looks like Ingrid starts, that's something, again, you might be wondering. So whatever you type down and put down, hopefully you were thinking about the things that we've been uncovering, like walking rates and speed, and maybe even looking at the point of intersection, all of those sorts of things. Okay. All right, so Ingrid stops at Tara's house on her way to school. Tara's mother says, Tara left 5 minutes ago. Ingrid leaves Tara's house. Okay, we have the same situation or the same scenario. So, in what way is the situation similar to the race between Henri and Emile? Well, if you remember Henri and Emile, we were looking at two brothers who were doing a walking race, right? And the older brother didn't want the younger brother to know it was so obvious. He wanted him to win. And my mind is drawing a blank. I'm thinking that Henri was the older brother. I couldn't remember. Maybe Emile was the older brother. In any case, but it's similar because with Henri and Emile, the question asks which person's traveling at the greater rate to catch up. So in both cases, the person traveling at the slower rate had a head start. So Tara's head start is symbolized by this right here. We notice Tara did not begin at 0, 0. So she had a head start. Why? Because her mom told um, Ingrid, she said that she left 5 minutes ago. And so in this particular case, that head start is symbolized by that 500-foot distance at point 0. That makes sense. Okay. And so in any case, when we look at it, the head start is given as time rather than distance in this case. So although we know like the time was 0, but the distance was 500, really the time was 0. So even though she did get a 5-minute head start, it's not showing it as time 5 minutes head start. It's not showing us to go from here, starting here. The graph still has X at 0, but the distance happens to be 500. That's what that is, how that's similar to Henri and Emile's situation. And so after how many minutes does Ingrid catch up with Tara? Well, what do you see? 4-minute mark, right? Because they're both at this point of intersection where both graphs intersect and actually just stop, boom, right here at the 4-minute mark. Okay. So here is Tara walking along. After 1 minute, she's got, I don't know, the midway point between 500 and 750. Yeah, let's call it 625-ish. And then at the 2-minute mark, she's at 750. So she's just kind of slow and steady here. Here, 1-minute mark, 250, boom, 2-minute mark, 500, bam, 3-minute mark, 750. So she's moving. Ingrid is over here booking, which gives us the answer to our last question, which really talks about, each graph intersects the distance at the y-axis. What information to the points of intersection give you about the situation? Well, the intersection of Tara's graph at 500 means that when Ingrid started walking fast, Tara was 500 feet ahead of her already. So Ingrid's like, let me start moving, boom, but Tara's already at 500. Right? So the time is both 0, but she was already at 500 feet ahead. She was nowhere. And so that's what that means. The intersection of Ingrid's line at 0, right here, Ingrid's line is 0, means that Ingrid was at Tara's house when she first started walking. And we know that Ingrid was at Tara's house, right? Because Ingrid left Tara's house and her mom had said, oh, shoot, she left 5 minutes ago. So she's now booking it. And this is more real life context. So I know this is going into detail and probably giving you more information than you need, but I really want to make sure you're understanding it from not only just the math, the answers standpoint, a conceptual understanding, and a real world situation that makes sense. Okay. And so What this means here is that really the intersection of Ingrid's line at 0 was that Ingrid was at Tara's house and she started walking fast. And Tara was already 500 feet. She was already at 500 feet when Ingrid started in both of her when the time was at 0. Okay. Which line is steeper? Clearly, we see Ingrid's line is steeper. It's like almost like she's going. Whoa. So steepness really is going to come in our next few investigations when we look at rise over run. But think about it. If I'm going on a hill and the hill just is kind of like this, as opposed to the hill being like this, which hill is steeper, right? The hill that obviously is like a peak and an incline, and not so much that it goes on longer, but it just goes up at a quicker rate, right? Okay. This table was almost an insult to your intelligence. Come on, people, you know this. If we're looking at in a table, the first value being X, the second value being Y. In this case, this was really N, and this was C. So cost is 5N. 0 times 5, 0. 1 times 5, 5. 2 times 5, 10. 3 times 5, 15. 4 times 5, 20, and so on. And I just put this in the table just because I want you to remember that these are things that you're going to be required to do. And come Thursday, when we meet again, we're going to be doing an assessment to kind of see how we've really looked at all of the things in investigation 1 and 2. Okay, I started plotting the points already so that it would save some time. And so we know 0, 0 is here. When X is 1, Y is 5. When X is 2, Y is 10. When X is 3, Y is 15. X is 4, Y is 20, and so on. And I didn't bother plotting the other points, but we do know that it is a linear relationship. It forms a straight line. It is going up pretty steeply. Okay. Now, the next few questions, they're a little more challenging. I'm not going to lie. These are questions that require you to think. So how did I come up with the equation y equals 100 plus 3x? Well, first of all, I saw that at 0, it was already 100. So that tells me I'm going to have a constant term. A constant term that is going to be in each part of my equation. Then I'm also going to have a variable and a coefficient. And that variable, once I plug it in with a value, is going to change what y is. And so first comes x, then comes y. First comes x, then comes y. Well, first comes x. We know that y is equal to 100 and something else going on. Well, I see 103, 106, 109, 112, 115, 118. I can assume that this is an increase of plus 3, plus 3, plus 3. And not even assume, I can see in the pattern. So I know, and my evidence shows it, right? And so in this case, the equation has to be that every time I look at x, I'm going to have 100 plus whatever the value of x times 3 is. Whatever the value of x times 3 is 6. X times 3, 9. 4 times 3, 12. 5 times 3, 15. But I also need to include my 100 added to it. And so that's why that looks like that. Now, these questions, I'm not going to pretend, like I said before, that they are easy. These next ones are ones that I chose specifically when I made the Pear Deck. I said, you know what, I'm going to really, really make sure that students are in a position where they are getting accustomed to the types of questions that are being asked of them in this case. So in this, it says, suppose each of the patterns, I'm sorry, to circle the tables that show a linear relationship. And so the tables that show a linear relationship in this particular scenario are negative 10, 0, 10, 20, 30, negative 29, 1, 31, 61, 91, A. Why? Why does A show a linear relationship? Well, because 3x plus 1 is what that graph shows. Now, what else shows a linear relationship? B. How so? Well, because when we look at it, B, the equation is 2x plus 7 equals y. And so A and B. Now, I'm going to go into a little bit more depth with that concept when we do our Google Meets, because I really want to talk about it so that people are able to ask and answer questions. But always think about this as, if I'm looking at this as a coordinate graph, that's one thing. But I also have to just plug in the values. 3x plus 1 equals y. Well, what is y saying that it is? In this case, it's negative 29. Okay, well, what is x? Negative 10. So 3 times negative 10 plus 1 is what I'm looking at. And does negative 30 plus 1 equal 29? Yes, so that's now that particular equation that works and that plugs in. Is it going to form a straight line when I graph it? 0, 1, 10, and 31. So I'd have to even think about sketching it out or possibly even graphing it out. And again, I'm going to give you a few more strategies of how to determine which ones are linear and which ones are not. And in some of the cases, you can just tell because you're looking 1, 2, 3, 4, 5. Okay, is this increasing by, this is going by 1, 1, 1, 2. No, this would need to be 2 in order for that to be linear and form a straight line, right? This is 1, 9, 5, and 22. So some of these we're going to be able to tell off the bat they're not linear because of the way that the x and the y values don't vibe. Okay. All right. And so in these last three, again, another challenging set of questions in the sense that it's something new. And so one of the strategies and techniques that I'm going to tell you to use is just plug it in, plug in the value. Use this particular equation right here and set it up as, okay, I need to fill in something for x, and y should be what y shows. And so, for example, I look at graph 3, and that's the answer for this particular one. Well, what is this coordinate point? 0, 5. So now 0, 5. Okay, well, 3 times 0, what's that? 3 plus 5, 5. And so does that work out? Yes. All right, what about this point? This looks like this is, there's another point that looks like it's actually right on the line. One that looks like 8, right? Does that work? Let's over 1 up to 8. 1, 8. Or what's 1 times 3? 3. What's 3 plus 5? 8. So that works. So basically what I'm doing is I'm taking this equation and I'm substituting what x should be. That's x over 1. I'm going to go ahead and solve it. And that's what y is. It is 8 because it's over 1 up 8. Here, over nothing, 0 up 6. And so that's how I know that that's the graph for that. The same thing goes here with the equation x minus 7. And so in this particular equation, you're looking at, okay, all right, graph 4. Where is there an actual point that I can look and see? 0 over, oh, I'm sorry. So now we're going over to 5, 5, 6, right? So this is 7, 7, 0. So it's over 7, but it's not up or down anything, right? Over 7, pardon me. Because first comes x, then comes y. So 7, 0, right? Well, look, x minus 7. And so let me put in what x is. This is me plugging in now. 7 minus 7. What's 7 minus 7? 0. Is this coordinate point 7, 0? It is. Look, what about this one? Now this one is 0 at negative 7. So this is the coordinate point 0, negative 7. All right. Well, let me plug it in. What is x 0 minus 7? What's 0 minus 7? Negative 7. Is this point 0, negative 7? Yes, it is. Check it off. And so really what you're doing, you're looking at, okay, in this line, where can I see an actual value that is not in between? Like I would choose something that is not in between the two lines. Like this wouldn't be good to choose, that wouldn't be good to choose, but boom, that's an actual point. That's a dot that I would have plotted and I could see and I can look and see, okay, well, this is over. If this is 4, I'm assuming this is 2, but that's 4. And this is 2, 4, 6. Okay, so this is over 4, -4, down 6, -6. And so now when I plug that in, is -4 plus 7 going to equal -6? No. -4 minus 7, rather. No. So that's what I have to do is I have to do two things. I have to first see what's the coordinate point. So that seeing the coordinate point is like saying, what is X? What is Y? A point anywhere on this line. Then I need to go ahead and plug in the equation and see if that works. And then the last one, -x minus 10 is graph 2, and you use the same technique. Let me see, where is there a point? Okay, I'm looking at, this is 2, 4, 6, 8. I'm assuming this is 8. So boom. Over to the left, -8, and down, if this is -4, that's -2, right? 4, 6, 8. Okay. And so now I have to plug in, is -8, -x minus 10 going to give me what y is? Okay. I'm going to go over these again a little further when we have our Google Meets, which will be tomorrow, Tuesday, 9 o'clock. I'm going to post this video just for those of you who want to view it ahead of time and go over the answers so that you're a little more comfortable. I will be going over these same answers and a little bit more detail tomorrow. But again, just please make sure you're staying tuned for anything in Google Classroom. We will be meeting AMS every Tuesday, every Thursday from 9 to 11. And I guess I'll see you guys tomorrow.